Okay, this slide will show you how to derive the state diagram of the given FSM circuit. Okay, so previously we only derive the from the state diagram, and then we draw the truth table, and then draw the K-map, get the equation, and we can draw the circuit. But how about if the question asks you in reverse engineering? Okay, the question give you the circuit, and the question asks you how you want to derive the state diagram, or get sorry, or how you want to get the state diagram from the circuit. Okay, for example, we have this circuit. So first step, you have to get the equation, read the equation from this circuit. So obtain the Boolean equation for D0, D1, and Y. So due to we have two flip-flop, so we have to derive the D0 and D1, and also output Y. Okay, so Y is equal to Q0 dot I, and D1 is this one, and D0 is this one. Okay. Second, obtain the standard SOP form of the Boolean equation. Since there are three variables, Q1, Q0, and I, so for each term, the standard form must be in these three variables. Okay, we have to remember back what is the standard SOP. Standard SOP means this equation for standard SOP, they have three variables, Q1, Q0, and I. Okay, this equation is actually the minimum or minimized equation. So we have to expand this minimized equation to standard SOP, that each term should have three variables. Okay, for example, y. So y equal to q0 and I, q0 and I dot I. So the missing variable is q1. So q1 we have to put with q0 and I. So q0 and I is 1, 1 because doesn't have bar here. So another variable is q1. So the missing q1 is 0 and 1. So meaning that in truth table for output y equal to 1, the input for q1, q0, and I is 0, 1, 1 and also 1, 1, 1. Okay. Okay, and then for D1, equation D1, so I bar plus Q1 dot Q naught bar. Okay, I bar plus Q1 dot Q naught bar. For I bar term, the missing variable is two variables, Q1 and Q naught. So I bar means 0. Okay, because they have this I have bar. So make sure we arrange the missing variable in sequence MSB and LSB. So the MSB is Q1, the LSB is I. So we have to draw like this, Q1, Q0, and I. Okay, I here is I bar, so I bar is 0. So the missing variable is Q1 and Q0. So due to two variable or 2 bit, so we have to write like this 0, 1, 0, 0, 0, 0, 1, 1, 0, and 1, 1 because the missing variable is in two variable or 2 bit. Okay, another term is Q1 Q0 bar. The missing variable is I. Okay, Q1 and Q0 bar in bit represent by 1, 0, so 1, 0. So because due to one variable only, so the missing I is 0 and 1. Okay, so meaning that for D1 in truth table is equal to 1 when the truth table input for Q1, Q0, and I is this one 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 0, and 1, 0, 1. if they have equivalent input. For example, this one 100 and 100, so it's okay. So meaning that 100 D1 will be 1. For D0 equal to Q1 bar dot I, okay, plus Q1 dot Q naught bar I bar. Okay, for this term is okay because Q1, Q naught bar and I bar is already in 3 variable, so doesn't have, they have no missing variable here, so leave it like that. So Q1 is 1, Q naught bar is 0, I bar is 0. Okay, for Q1 bar and I, the missing variable is Q naught. So we have to put Q naught here because Q1 is MSB, I is LSB. So Q1 bar is 0, I is 1. Sorry, so this one you have to change from 0 to 1. Okay, so this I is 1, okay, not 0, 1. So Q1 bar is 0. So the missing variable is Q naught, 1 bit. So 1 bit Q naught is 0 and 1. Okay, so this is the standard SOP for each equation. Okay, then next, the standard form in step 2 represent value 1 in the truth table for Y, D1 and D0 as I mentioned before. Okay, all the standard form represent output 1. For this one is Y equal to 1, this is D1 equal to 1, D0 equal to 1 in truth table. Okay. Okay, for example, Y. Okay, Y, this is Y column. Okay, output Y. So when the Q1, Q0, and I is 0, 1, 1 and 1, 0, 0, 1, 1, 1. So the output Y will be 1. So which one is 0, 1, 1? So this is 0, 1, 1. So the output Y will be 1. Okay. And another one is 1, 0, 1, 1, 1. So 1, 1, 1, the output Y will be 1. So because due to only two input, okay, that will give output Y equal to 1. So other than that will be 0. Okay. For D1, see this D1 column here, D1 column. So 0, 0, 0, D1 will be 1. Okay, 0, 0, 0, D1 will be 1. 0, 1, 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 0, 1, 1, 1, 0. So 1, 1, 0, 1, 1, 0, 0, already done. Okay, already done. So 1, 0, 1, 1, 0, 1. So this is 1. Okay, so okay. And then next, other than that will be 0. For D0, 0, 0, 1. Okay, D0 column 0, 0, 1. D0 will be 1. 0, 1, 1. 0, 1, 1. D0 will be 1. 1, 0, 0. 1, 0, 0. D0 will be 1. So other than that, the D0 will be 0. Okay, so after complete this output D1 and D0 inputs, so we can fill in this next state by looking the present state and input flip-flop. Okay, for D flip-flop is very simple, like we did before. For next, when we get next state and when we use D flip-flop, so we just copy next state to D flip-flop. For this reverse engineering is similar. The D flip-flop input we can copy to be next state. Okay, so like this. So copy and paste here. Alright, so we can, since the D flip-flop is used, therefore next state is equal to the flip-flop input. Okay, you can also figure out the next state for T or JK flip-flop, meaning that if this one is T flip-flop, T1, T0, so we have to analyze bit by bit. For example, T for T flip-flop, different input will give output 1, similar 0. Okay, for example, this is 1, so 0, this is 1 for T flip-flop. Okay, so 0, this one will be 0. Okay, and then for JK also we can complete the next state by analyze the flip-flop input and present state. Okay, draw the state diagram based on the derived truth table in state 4. So after we complete the truth table, so we can draw the state diagram. Okay, state encoding. So present state only have 2 bit, so 2 bit maximum is 4. Okay, so we have S0, S1, S2, and S3. 4 state. S0, S1, S2, and S3. Okay, S0, S1, S2, and S3. And then to draw the arrow, input output, so we have to analyze each row. For state 0, S0, input 0, next state is 1, 0. 1, 0 means S2. Okay, S0, input 0, next state will be S2. Output is 0, input 0, output 0. Okay, and then still S0, input 1, next state will be 0, 1. S0, input 1, next state is S1. Okay, the output is 0. Okay, input 1, output 0. And you can draw for all input and output, and also next state we can connect by referring this truth table. So the answer is like this. Okay, so that's all for reverse engineering or derive the state diagram from the given FSM circuit. Okay, thank you.